Good evening, everybody. This is SLU. I'm Bob Berman with a special program today on the near close encounter with the asteroid 2000 EM26. And as it whizzes past our planet tonight, we're also going to be reviewing the extraordinary events of 1 year ago when Earth got actually struck, or at least our atmosphere did, by one major meteor, the largest in a century, in Siberia, while another, one of the largest asteroids in our lifetime, came closer to us than our geostationary satellites. Joining us will be Paul Cox, our technical director, coming to us from the Canary Islands, where the SLU's main facility is located, and also special guest, Dr. Mark Boslow, who is an expert at planetary impacts and global catastrophes. Dr. Boslow works at the Sandia National Laboratories, and it's we couldn't do better in having a person who will really tell us what the honest-to-goodness threat is. We're also going to look at some extraordinary images that have been collected from that event a year ago, and I want to first tell you that at the Canary Islands facility, we have so much snow and ice there that we are unable to open that observatory. In fact, the military have come up and offered to evacuate the people at the observatories at the sites there. Paul, you're standing by there, aren't you?
That's right. Yes, Bob. We are basically marooned here. We're up at 8,000 feet at the Slough Canary Islands Observatory. It's on top of a volcano, basically, and we've had ice and snowstorms. I mean, it's just part of the global, really unusual global weather that everybody's having. But, yep, the domes are iced up, but we have got some images coming in from our partners over in the Dubai Astronomy Group, Bob, so we will have some images a little bit later.
Excellent. So we are waiting for this. Now, this asteroid 2000 EM26 is an asteroid that may be as large as 3 football fields. We're talking about 300 yards across. Perhaps it's only 200 yards across. We're unsure. It was first discovered almost 14 years ago. It's whizzing past us at 17,000 miles per hour at a distance of a little closer than 9 times the distance to the moon. So no need to worry. This is no chance that it's going to impact us. We're talking about a little over 2 million miles. What's interesting is that it's happening almost on the exact anniversary of these extraordinary events of 2 years ago. But just as interesting, when it was discovered, it was classified as a potentially hazardous asteroid. And yet, as it circles the sun, when it was looked for again in 2006 and 2009, it could not be found. So this particular asteroid has not been recovered, has not been seen since 2000. So what we're attempting to do tonight is point our telescopes to where we expect it to be. And if we see it, well, that's going to be historic because we've reacquired a potentially hazardous asteroid. If it turns out we can't see it there, we're going to be asking, well, where the heck is it? And losing track of a potentially hazardous asteroid will, again, highlight the fact that there's a lot of stuff going out there that can do us harm. We don't want to overemphasize the dangers, but we certainly don't want to minimize them either. And so this is the perfect time to bring on Dr. Mark Boslow. Welcome to the show, Mark. Glad to have you.
Thank you. Good evening.
And what are your thoughts on this anniversary of the events of a year ago? What do you take from that?
Well, of course, it's been just over a year, and I've been thinking about it a lot. Of course, people have been asking me a lot of questions about what I was doing a year ago at this time, and I was getting ready to go to Russia. The events of February 15th were really amazing. I mean, it was one of those things that you don't expect to experience in your lifetime. And, you know, the most amazing thing about it is it happened over a populated area. And so there were all these dashboard cameras that observed this. And so it was really well documented, even though it was just serendipitous. It was an accident that it came in over a populated area.
Now, while you're speaking, Mark, we are showing our viewers the video, a colorful video of the airbursting asteroid over a series of buildings. And so can you comment on that?
Okay, I can't actually see that on my screen, but it may be one that's shown from the north. It's going from left to right.
Correct. Yes.
It shows that it's coming in at a grazing angle. You can tell that from the video that it didn't come in at a very sharp angle, and that turns out to be very lucky. It turns out to be lucky from a scientific perspective because it took a long time to traverse the sky, and so we got a lot of data. And it also turned out to be lucky from a sort of a hazards perspective because it traversed so much atmosphere that it used up all of its energy before it got deep into the atmosphere and close to the surface. So all that energy stayed away from the Earth's surface, and so the damage was not as severe.
Yes, we're seeing a cloud of material that's expanding so rapidly in this colorful video that even the smoke from the chimneys in the foreground are barely moving by comparison. It just shows how rapidly, it must be supersonic, certainly.
Okay, now I see what you've got up on the screen, and that's actually a simulation. That's our computer model of the event. So this is not one of those dash cam videos. This is what you see is a cloud. The glowing cloud
Yes.
is from the energy that was deposited in the atmosphere, and we use the data from the actual event to initialize this simulation. So this is a 3D computational simulation using a hydrodynamics code that was developed for nuclear weapons simulations.
Excellent. And I believe that Sandia nuclear weapons is something you do there, isn't it?
That's our primary business.
So, and I believe we'll now show a simulation or a calculation on a graph showing what would have happened at the atmosphere and why this burst meteor did the damage it did. Yes, I don't know if you can see that now.
I can see I've got a lag from what I'm watching, but if it's coming at a deep angle, I'm kind of showing the difference of if it had come in at 19 degrees from the vertical rather than 18 or 19 degrees. 10 times bigger in terms of mass. That's roughly twice the diameter. It was about I think about 40 meters in diameter or 20 feet or so in diameter. So in order of magnitude more energy, and it also came at a deeper angle. It came about 35 degrees, twice the angle, and because it had so much mass and more energy, there was a lot more to the surface. So that knocked over these or an area of over a couple thousand kilometers, almost 1,000 miles.
Now, an exemplary impact of global catastrophes. It's my understanding that you have concluded, after studying this your entire life, that the chances of an object of this size doing us harm is actually greater than we used to think. Is that true?
Well, I'd like to clarify that. So, I think the assessed risk, the actual risk hasn't changed. It's really our assessment of the risk that's changing as our understanding develops. And our assessed risk of the small ones, the air-bursting ones like Chelyabinsk and Tunguska, that is increasing. We think they happen more often than we used to think, and two, they're more dangerous. More of the energy gets to the ground for a given amount of energy than we used to think. So our estimate of the risk from those is greater, but our assessment of the risk from the really big ones, the one that's flying by tonight, and bigger ones, our assessment of the risk from those is going down, and the main reason is that we're discovering them, and the ones that we're discovering are not on collision courses. The ones that we're discovering and we can keep track of, that is.
Fascinating. And obviously this has grabbed NASA's attention because just this past September, NASA held a what they called an Asteroid Grand Challenge workshop, and our technical director, Paul Cox, was there for SLU. Paul, is that true that NASA wants the public to be more aware of this danger?
Absolutely, Bob. And, they told us when we were there that, the reason why they invited us was a couple of years ago, this kind of came to, a peak at SLU. And we started seeing these near-Earth asteroids discovered within a couple of days of them making their closest approaches to Earth. And basically, we started a campaign and we started showing these objects live. We've got a whole bundle here, just some of them discovered a couple of days before they were making their close approach to Earth, well inside the orbit of the Moon. And NASA invited us there to make a presentation to the Asteroid Grand Challenge workshop. And we are now partnering with NASA to really expand an observing campaign. So we are trying to enlist a legion of amateur astronomers, citizen scientists to help, using the SLU telescopes, to help track and characterize these near-Earth objects so
Excellent, and we're seeing that right now. I don't know if you can see what we are showing the public, but these are actual images that you were responsible for using the SLU equipment of tracking, and it's very difficult to track a very close asteroid as it moves quickly across the sky. But we're looking at Near-Earth Object 2012 DA14 as it's speeding against the background stars right now.
Yeah, and what we've already got, Bob, is a number of SLU members, part of what we call the SLU Research Group, and they are already involved night after night in tracking these objects. So predominantly newly discovered objects, which we don't fully understand their orbits. We don't have their orbits determined very accurately. So the SLU members, they're using the SLU telescopes. They take these images, and you can see how difficult it is, even when you know where one of these things is, how difficult it is to actually spot them in one of these images. Well, they perform what's called astrometry on these images, and they make submissions to the Minor Planet Center, and that helps accurately determine the orbit of these newly discovered near-Earth asteroids, so they don't follow in EM26's way of being observed, being discovered, but then lost for a decade.
It will be fascinating to see if tonight we can reacquire this asteroid that's passing, and we might as well tell everybody it just passed in the past hour, just 8.8 moon distances from Earth. Now, that may seem pretty far away, almost 9 times the distance to the moon, but that's still a good 15 times closer than the nearest planet. And so we need to keep track of these objects. If you're just joining us, this is Paul Cox, Technical Director. I'm Bob Berman, SLU astronomer and author of The Sun's Heartbeat. And we have our guest, Dr. Mark Boslow, who is an expert on planetary impacts and global catastrophes. Mark works with Sandia National Laboratories. He has just told us that the assessed threat has been changing and upping the threat for us getting hit by an object of the size that burst over Siberia a year ago, although the threat of an extinction level event, such as the one at the KT boundary 65 million years ago that got rid of the dinosaurs and paved the way for the ascendancy of us mammals and rats and sitcoms and all the things we have today, that was made possible by that incoming object. That threat is actually reduced. Now, we're going to show an image now from some webcams from the event from a year ago, and I would love for Mark Boslow to comment. Now, we're going to use some webcams in Russia to see this incoming object that happened on February 15th, 2013. And we're seeing it now moving across the sky from left to right. And what do you take away from this, Mark?
Okay, so if you're showing the one I think you are, it's coming in from the left and it starts to glow and it gets really bright, and then you see it explodes and then it leaves a trail.
Exactly.
And so what I and others were able to do was to calibrate these YouTube videos, these dash cam videos, and determine its trajectory precisely. And then what my colleague Peter Brown and his group did was they were able to extract the brightness as a function of time and position along that trail, and from that we could infer the amount of energy that was deposited in a parcel of atmosphere along the trajectory, and then I could use that to initialize my simulations, what you were showing earlier.
And the amount of energy, as we again see just these fantastic images of it coming in, was greater than a nuclear bomb explosion, was it not?
That's right. It was about, our estimate has significant uncertainty, but our best estimate is about a half megaton.
Half a megaton, which of course
half a megaton. And that comes from multiple independent sources of information, from infrasound, the very low frequency sound waves that you can't hear that traverse the entire planet, and from the period of that infrasound wave, that period correlates with the yield of the explosion, and that was one way of estimating it. That was one of the early estimates, and all the estimates seem to be consistent.
My goodness, that's more than 20 times the explosion of the Hiroshima bomb over Japan. This was quite a burst, and it was something like 18 miles up, was it not?
That's right, yes. I mean, it traversed a lot of sky, and it was descending while it was, but the main explosion was between 18 and 20 miles up.
All right, what we're going to show now are some of the other videos from that event from a year ago, and both from
some of these
camps.
And I don't know if you're playing the sound, but some of them are quite spectacular in the booms, the ones that are directly beneath.
And it must have taken some time for the sonic boom to arrive. As I understand, there were 1,500 injuries from broken glass, flying glass.
That's right, and of course, what happened was, the bright flash in the sky and the strange cloud drew people to the windows. It was early morning; people were already at work, and they started, looking at the sky through the windows. And it took a couple, 2 or 3 minutes, for the blast wave to get there, and it was so strong that it blew out the windows. And most of the people who were injured by flying glass.
We're now showing some pictures from, it looks like in a warehouse, of the blast blowing down a door right on top of some unfortunate people who were just exiting that door at the time. And,
and you can see, that where there's a structure, the pressure builds up. There's a dynamic pressure, but then that blast wave reflects off the surface, and so the pressure builds up, and there's more pressure outside than inside. And so the building, whatever the weakest part of the building is, whether it's a window or a big garage door in a warehouse, it blows in. And it blows in with a lot of force.
Now, you started your interest in this, I understand, even in childhood when you observed the Perseid meteors, the great August 11th shower that many of us love to see. But back then, you didn't just merely count meteors. Tell us what really started you on this. What did you do during these meteor showers?
Well, as a kid, we were Boy Scouts, and we used to camp out in our backyards, and we'd do this every August, and we'd just, get out of our tents and lay in the backyard and watch the sky. I grew up in Colorado, where it was usually clear in the summer, and it was just very mesmerizing and magical to see these, flaming dust particles traverse the sky. And then in 1972, our family happened to be taking a vacation in the Tetons, and there was this great fireball of 1972, which we didn't see. We were there, but we didn't see it. But we talked to people who did, and much later, I learned that it had been recorded on one of those old Super 8 film movie cameras, and had gotten shown on TV. You can find that on YouTube now.
And then you did experiments with objects flying into mud or impact?
Yeah, then I majored in physics, and I went off to Caltech to do my PhD research and started making craters using hypervelocity launchers and very high-speed guns to fire projectiles into targets, and looking at the effect that the high-velocity collision had on the targets, looking at the temperatures of minerals and making craters and looking at the properties of the craters that formed. And then I got a job at Sandia, and I got to keep doing similar things.
It's hard to believe you actually got paid to do what probably every boy in the world would have loved to do.
I got paid to shoot big guns and to blow things up. Now I do it all on computer. I've jumped from experimental to computational physics, which lets me do things that I can't do in the laboratory, like, set off half-megaton explosions.
We're going to now show an image taken apparently in the west of a fireball going across the sky, and this is one that you've supplied, showing in this case it's a fireball, looks like going from right to left and either impacting or blowing up in the air in a desert-like setting.
I think I know which one you're talking about, and that's the one, that's also a simulation, and it's a simulation of that I did back in the 90s, showing what a Tunguska-like impact would be like if it happened in New Mexico and you're looking at the Sandia Mountains, you're actually looking down my driveway.
It looks like you have dark skies there.
Yeah, I can see it now. And so what I was illustrating with this was a plume. So when you have a steep impact, you get this giant plume of vaporized asteroid mixed with hot air that expands into space above the point of impact. We didn't see that for Chelyabinsk, and it's because it came in at such a shallow angle. The plume formation apparently requires a steeper angle.
I see.
Oh, excuse me. May I just
Yes,
interrupt for a second?
Please.
Just to let you know that we have got some images now coming in from Dubai. They are transferring over to the USA for our producer. He's going to be showing those very shortly. Now, what viewers have got to keep an eye open for, it's a series of images. And what we're looking for is one of the small dots to be moving from one image to another. Now, don't forget, this thing hasn't been observed for 14 years. To all intents and purposes, it's lost. So if we actually spot that moving object in one of those images, we have reacquired or rediscovered this particular asteroid, this potentially hazardous asteroid. So those images are coming up, folks. Sorry, it's taking a bit of time to get them from Dubai and fed through to us, but they are on their way very shortly.
Excellent. What we're talking about is tonight's, I don't know if we can quite call it a near miss, because the asteroid 2000 EM26 is passing a little bit closer than 9 times the distance to the moon. So those who think that, I know we always have some people who think the government has been covering something up and we're really in imminent peril of being clobbered. No chance of being clobbered tonight. However, this is an object that may be as large as 3 football fields. It's a substantial asteroid, passing us at a rate of 17,000 miles an hour. It's not an easy object. It's at magnitude 16.1. That's the projected magnitude. It means it's fainter than Pluto, and acquiring it is not easy, but that is what we are attempting to do. And considering that this is close to the exact anniversary of the amazing events of a year ago, it's very exciting. And in case you forgot what happened a year ago, we have Dr. Mark Boslow, who has been reminding us that on the very day that we had 1,500 injuries over the city in Siberia, Chelyabinsk, because of an air-bursting incoming asteroid that had not been discovered ahead of time. It came at us, nobody knew it was coming, and on that very same day, by extraordinary coincidence, we had the probably the largest asteroid that came closest to us in our lifetimes, the asteroid DA14, 2012 DA14, that actually passed nearer to us than our geostationary satellites. And that one, we can show you that one in a moment. Here it is. As SLU tracked it, this is the SLU Community Observatory. Our members are watching the skies every night, taking turns using the automated observatories on the Canary Islands. Tonight